Algebra 1. It's another day, another time to learn a little bit of math. Here's a warm-up for you. What are the four properties that we, this should say we, not say, have used so far to solve equations? You can go ahead and pause the video and maybe even look back in your notes and find the four properties that we have talked about so far. All right, so hopefully you had some time to look those up. The four properties that we have used so far are the addition property, and it's technically the addition property of equality, but if you just put addition property, that's fine. There's also the subtraction property, and I'll put OE of equality. And then let's see, addition, subtraction, what's the next one? Multiplication. Multiplication property of equality. And then the last one, you guessed it, the division property of equality. Math comes with these properties because they're like the rules of solving math problems. The addition property, the subtraction property, and multiplication property and division properties all give us the method or the rules for undoing numbers so that we can find the variable value. The addition property says that you can add the same thing to both sides of an equation. The subtraction property says that you can subtract the same value from both sides of an equation. Multiplication property, you can multiply both sides of an equation to solve, and the division property says that you can divide the same value on both sides of the equation. These properties are really important, and you use them over and over again when you're solving equations. We're going to talk about another one today that is going to be super handy. But before we do, it's time to get out your notebook if you haven't already. Pause this video, find a set of notes where you haven't written questions yet, and then also write a summary for one set of notes, and then get a page ready for today's notes. So go ahead and pause and update your notebook. All right, on your new set of notes, let's start. So the topic is the distributive property. That's the new property you're going to learn today. The essential question, how could you solve problems using the distributive property? Make sure that topic makes it into the table of contents of your notebook, and let's get started. So, like I said in the warm-up, so far you know four properties of math, and they've been extremely helpful in solving problems. We're not actually going to be solving problems with the distributive property today. We're going to be simplifying expressions. Soon we will work the distributive property into equation solving, but I want you to see how it works first. The distributive property says this: to solve problems or simplify expressions, you can distribute values into parentheses. To solve problems or to simplify expressions, you can distribute values into parentheses. It can also be written like this: A times B plus C equals AB plus AC. What this is saying is, notice how A is outside of some parentheses. In order to simplify, you can distribute that A on each one of those terms, B and C, and get A times B plus A times C. Now here's why this thing is handy. If you have a little problem like this one, 2 times 3 plus 4, you can follow the rules of the order of operations and get the answer to this problem. You can first notice that you have to take care of what's inside of parentheses and add that 3 plus 4, and so have 2 times 7. And then you can do the multiplication step, following the order of operations, taking care of what's in the parentheses, and then the multiplication, and get 14. But what the distributive property tells us is that we can take this same 2 times 3 plus 4 and distribute that 2 onto the 3 and onto the 4. Here's what I mean. I can take this 2 and I can multiply it by the 3 and get 6. And then I can take this 2 and multiply it by the 4. Let's not forget our plus sign. 2 times 4 is 8. And now we can simplify 6 plus 8. What is 6 plus 8? 14. We got the same number in both cases, which tells us that we're essentially doing the same thing. You can solve when you have all numbers either way. It really doesn't matter. But look at this other little expression. 2 times x plus 4. Now, we're not going to be able to get rid of those parentheses by operating inside them. X plus 4, this right here, cannot be simplified because they're not like terms, like we've talked about before. X's and 4's can't be combined, but we still need to get rid of those parentheses. And this is where the distributive property comes in. We can simplify this expression by distributing the 2 onto the x and onto the 4, just like what we did before, except now our answer isn't going to be a single number. So we have 2 times x, or 2x, plus 2 times 4, which is 8. And that is the best we can do, because 2x is a term that has an x in it, and 8 is a constant term, and variable terms and constant terms cannot be combined. So maybe it doesn't really look simplified at this point, but it will. It will be very helpful as you go forward and you add the distributive property to your bag of tricks when you are solving equations. So we're going to use the distributive property with variable expressions like the 2 times x plus 4 a few times so you can see how this works. So here we have one that says 2 times x plus 10, or 2 times the group x plus 10, or 2 times the quantity x plus 10. We want to simplify, and when we're simplifying, we're trying to get rid of the parentheses, but we can't do anything inside the parentheses because x plus 10 doesn't make any sense. You can't combine anything. And so in order to get rid of the parentheses, we're going to have to distribute the 2 in using the distributive property. So first we have 2 times x, or 2x, plus 2 times 10, which is 20. And that is done. You just take the number that's outside and you distribute it into those parentheses, and that gets rid of the parentheses for you. All right, let's see another one. Now, it turns out it doesn't matter what order you do this in if the number that you're distributing in is on one side or the other. This way, we're still going to distribute, but we're going to distribute kind of going backwards. M plus 3 cannot be simplified, and the parentheses around the negative 4 are just reminding us that we're going to be multiplying that entire quantity, negative 4. We don't want to forget about the negative. But we can do the same thing. Here we can distribute that negative 4 onto that positive 3, and we can say that we have negative 12. And then we can take that negative 4 and distribute it onto the m, and we have negative 4m, and there is as simple as it gets, because we don't have like terms. And so negative 4m minus 12 gets rid of the parentheses, which is what we wanted to do, and that's as simple as it gets for now. Okay, here comes another one. So again, we want to get rid of the parentheses. Notice that there's 2y minus 6 inside the parentheses. Those are not like terms, so they cannot be combined. And so in order to get rid of the parentheses, we have to look to that negative 3 and use the distributive property to get rid of the parentheses. So we're going to take this negative 3 and multiply it by 2y. Well, what we do here is we multiply the coefficients. Negative 3 times 2 is -6, and then that y just comes along for the ride. Then we're going to take -3 and multiply it by -6. What's a negative times a negative? It's always positive. And what's 3 times 6? 18. And there you go. That's as simple as it gets. Once you have no way to combine like terms anymore, and you've gotten rid of your parentheses, that's as simplified as your expression can be. The bottom line is, distribute the number outside into those parentheses, but pay close attention to the negatives. So it can get a little bit scary. Now look at how this one's different. We've got 3 times the quantity 5x plus 4y minus 3z, and we want to simplify this a little bit. Well, the idea is going to be the same. In order to get rid of those parentheses, we can't simplify inside the parentheses because 5x, 4y, and -3z are just not combinable. They're not like terms. So we're going to get rid of the parentheses by distributing the 3 in. And so we have 3 times 5x, or 15x. And then 3 times positive 4y, for positive 12y. And then positive 3 times negative 3z. A positive times a negative is negative 9z. And now we don't have any like terms, and we also don't have any parentheses, and that's how we know that we're done. So it can look a little scary, but it's really just the same idea. You just distribute that 3 onto each one of those terms inside the parentheses, paying attention to pluses and minuses, and then you're done. Now, this looks really crazy, but it turns out that sometimes, in order to get rid of 2 sets of parentheses, you just have to do it more. You just have to do the distributive property more. Just looking at the first part, we have 5 times the quantity 2x plus 6, and then we're adding 4 times the quantity 4b minus 10 plus 2f. And we have 2 sets of parentheses to get rid of, but don't worry, we're just going to do it twice. We're just going to use the distributive property twice. So we'll take this 5 and we'll multiply it times 2x, and we'll get 10x. And then we'll take this same 5 and multiply it by 6, plus 30. And now we've gotten rid of the parentheses on that part. Now we get rid of the parentheses on the next part. We take this 4 and we multiply it by 4b, and we have positive 16b. And then this 4 gets multiplied by negative 10. Positive 4 times negative 10 is negative 40. And then positive 4 times positive 2s, f, is positive 8f. And then we can check it. Now let's see. We have 10x plus 30 plus 16b minus 40 plus 8f. Are we finished? Well, we got rid of the parentheses. But the other thing we have to check is whether or not there are like terms. Well, let's see. This 10x, if I look through the rest of this expression, I don't see any more x terms. But when I look at this 30, I see that I can match it with a minus 40. And so this still can be simplified. The 16b doesn't have any matches, the 8f doesn't, but we can combine those constant terms. So what we have is 10x, and then let's just add in that 16b, since we didn't do anything with it, plus that 8f, and now combine these terms. What is 30 minus 40? It's negative 10. And now we don't have any like terms anymore. And so we're done. So it's not just about distribution. Sometimes you have to take the extra step of continuing to combine like terms. And that's okay. Just keep looking at your expression and trying to find those matches. And even if it looks a little crazy, use the colored pencil technique that I talked about in combining like terms video, and you'll be able to get there. So let's dig into that a little bit more. Now that we've looked at both combining like terms and distributive property, we're going to put it all together again. So we have something a little bit shorter than the last question. 2 times the quantity 3x minus 5 plus 6x. Remember, the order of operations tells us to tackle those parentheses first. When we look inside the parentheses, we see that we do not have like terms. 3x and negative 5 are not like terms. And so in order to get rid of those parentheses, we're going to have to use the distributive property. So we're going to take this 2 and distribute it onto the 3x. What is 2 times 3x? Well, it's 6x. And then make sure you do the second term as well. That's one of the most common mistakes I've seen math students do. They only distribute the first term, but not the second. And we have 2 times negative 5, or negative 10. And then this plus 6x, we haven't done anything with it, so we can just bring it on down. Now let's check this. Do we have some like terms? I see some. We've got a 6x here, plus another 6x there. So we can combine those terms. 6x's plus 6x's are 12x's. And then this negative 10 doesn't have a match, and so it comes down. And that ends up being the end, because we got rid of the parentheses and we combined all of the like terms. So that's as simple as that gets. Now you can see that things actually do get simpler. At first it looks like it's kind of the same amount of complicated. But the first line, 2 times the quantity 3x minus 5 plus 6x, and 12x minus 10 are actually equal to one another. We've just rearranged things so that one is simpler than the other. All right, let's see something like that again. So now we have 3x plus 5 times the quantity x plus 2 minus 7. So this 3x, really nothing to do with it, because the first thing we got to do is get rid of parentheses, and we can't take care of the x plus 2 inside the parentheses, so it looks like we're going to have to distribute. But we're not going to distribute this 3x. You only distribute the number that is right next to those parentheses. Don't try to bring that 3x in as well. Just bring it down. 3x plus 5 times x, or 5x, and then 5 times 2, or positive 10. And then we didn't do anything with the negative 7, and so that comes down. So the distributive property got rid of the parentheses, but now it looks like we have to combine some like terms. What I see is that we have 3x and positive 5x as a pair of like terms. And then we also have this 10 minus that 7. And we can combine those like terms and get 3x plus 5x, or 8x. And these guys are done. And then 10 minus 7 is positive 3. We're done with those guys. And now this is a completely simplified expression. So you can see how this does actually simplify things. It's a matter of keeping track of the order of operations, taking care of those parentheses, and then combining some like terms. That's it, friends. That's the distributive property. And we're going to start throwing the distributive property into equations soon, but it's worth it to kind of just practice with it by itself. And so there's a quizzes on Google Classroom that you'll click into and do as many of the problems that you can. If you're finding that your quizzes scores are kind of low, you can always go back in and try it again. Maybe go back to the video and see what you missed. The essential question is, how can you solve problems using the distributive property? Hopefully you can answer that right now. All right, you guys, I hope that you have a great day, and I will talk to you again soon. Bye-bye.